For decades, the standard scientific assumption was that life began in a warm, chemical-rich pond right here on Earth. The idea was that our young planet provided the perfect primordial soup to brew the very first biological building blocks. But modern studies show a different picture. Early Earth's atmosphere was actually hostile to the synthesis of complex, reduced organic compounds. The chemical reactions required for life simply couldn't happen here. Because young Earth lacked the proper conditions, those initial chemical ingredients had to originate somewhere else. They had to form in the freezing, violent void of deep space. This creates an obvious roadblock. If the foundational ingredients for life assembled in a freezing vacuum thousands of light years away, testing exactly how they formed seems physically impossible. Researchers aren't building spaceships to solve this mystery. Instead, they are recreating the exact conditions of deep space inside glass vacuum tubes, right on top of standard laboratory benches. Teams from NASA's Cosmic Facility to a university lab in Sydney have built specialized chambers that isolate these extreme cosmic conditions. They trap glowing purple plasma inside spherical glass laboratory flasks. The first step is to engage powerful vacuum pumps to strip air out of the tubes. This mimics the absolute emptiness of the interstellar void. By physically trapping the extreme environment of the cosmos on a laboratory bench, researchers can directly witness and eventually reverse engineer the exact chemical steps that led to life. Once the tube is entirely empty, the scientists pump in a specific recipe of naturally occurring cosmic gases: nitrogen, carbon dioxide, and acetylene. But the raw gases alone aren't enough to trigger a reaction. In space, they required the explosive energy released by dying stars to force the molecules to interact. To replicate a stellar explosion in the lab, researchers blast the gas mixture with 10,000 volts of electricity. This generates a highly charged, glowing plasma. This miniature electrical storm proves that humans can accurately recreate the precise, violent conditions where interstellar matter is forged, all inside a piece of glassware. After the electrical blast subsides, a physical residue remains. A fine layer of synthetic, carbon-rich cosmic dust settles on the inside of the tube. Researchers Hugh Hill and Joseph Nuth found that this dust isn't dead debris. The material acts as a highly efficient chemical catalyst when basic elemental gases make contact with its surface. The dust forces these basic elements to break apart and recombine into carbon, hydrogen, oxygen, and nitrogen molecules, the essential organic building blocks known as CHON molecules. The dust inside the bottle is an active microscopic factory. It physically manufactures the exact organic ingredients required to start life. Creating synthetic dust on Earth provides scientists with something highly valuable: its exact, measurable infrared fingerprint. Astronomers take this specific chemical signature, calibrate their telescopes, and scan the expanse of the Milky Way galaxy looking for a match. And they find them. Telescopes detect perfectly matching complex molecules, including natural sugars, deep inside actual interstellar dust clouds, light years away. When these laboratory signatures align with the light coming from deep space, it confirms that the high-energy reactions triggered in a vacuum tube are creating the same complex matter found in the interstellar void. The essential ingredients for life were already circulating in our corner of the galaxy, long before the Earth even formed. These chemical building blocks are a constant output of the cosmos, forged in the energetic envelopes of stars, and then distributed across light years by supernovae. We are physically connected to the stars and the dust between them, and we verified that truth without ever leaving Earth, simply by trapping a piece of the universe inside a glass bottle.